Good morning, students. So we'll continue yesterday class. Now this is video class number 4. So yesterday we thought and many problems, many types of problems. A less than B, A less than B square, A less than B cube. Yesterday I explained these two problems. So next modulus of A minus B is even. Modulus of A minus B is multiple of 4. So this is A less than B, A less than B square, A less than B cube. These two problems I explained, neither reflexive, nor symmetric, nor transitive. Only the reflexive is okay, transitive also, symmetric is not. These two are always equivalence relation, okay? And today, another type problems. Show that this is class number 4, okay? So that the relation are defined in the set A of all triangles as are equal to T1 comma T2, so that T1 is similar to T2 is an equivalence relation. This was a very simple question. Just you have to write only. Reflexive, only writing is there. Okay. So what is R is defined T1 comma T2 so that T1 is similar to T2. We have to prove this is equivalence relation. Equivalence relation, the reflexive, symmetric, and what? Transitive. Then what is the first one? Reflexive. Reflexive, I explained many times. Reflexive, you have to select one element. We have to prove related itself. So, for T1 belongs to set A. Actually, when this is called capital T, because set of triangles. But instead of capital T is given A, so T1 belongs to A. T1 is for T1 belongs to A, it implies T1 is similar to T1. It is T1 comma T1 belongs to R. Therefore, R is reflexive on E. Very simple. The triangle T1 is similar to T1. T1 is here two triangles are there. Both triangles are similar. Whether you go to T1 is similar to T1. Triangle itself is similar. So T1 comma T1 belongs to R is reflexive. Then what is the next? Symmetry. So how many triangles you are selecting? Two triangles. T1 comma T2. T1 comma T2. symmetric. Let T1 comma T2 belongs to R. For all T1 comma T2 belongs to set A. It implies the triangle T1 is triangle. T1 is similar to T2. It implies T2 is similar to T1. T1 is similar to T2. T2 is similar to T1. So corresponding sides are proportional. It is similar meaning. So T1 is, these two triangles are similar. T1 is similar to T2. T2 is similar to T1. It implies T2 comma T1 belongs to R. Therefore, R is symmetric. R is symmetric on A. Even transitive also is very simple. T1 is congruent to T1 is similar to T2. T2 is similar to T3, and T1 is similar to T3. So you remember, my dear students, similar is always equivalence relation. Problem is very simple. But how to start? So you have to select one order pair. So T1, T2 belongs to set A. T1 is congruent similar to T2. T2 is similar to T1. So T2 comma T1 belongs to R. R is symmetric on set A. Then what is next? Transitive. Transitivity or transitive. Let T1 comma T2 belongs to R and T2 comma T3 belongs to R. For all a T1, T2 comma T3 belongs to set A. It implies T1 is similar to T2 and T2 is similar to T3. It implies T1 is to T3. T1 comma T3 belongs to R. Therefore, R is transitive. R is transitive on A. Or even it is transitivity on A. Hence, the relation R is an equivalence relation on the set of triangles A. So all the three conditions are satisfied: reflexive, symmetric and transitive. So this is a standard problem. Similar is always equivalence relation. And one more problem I will discuss with same type problems, that is called congruent. In congruent set of triangles only. Here also set of triangles. In congruent also set of triangles. The congruent is always equivalence relation. The three problems are very important. One is similar, congruent and parallel. These three always equivalence relations. Even it is given example of equivalence relation, these three are very important examples. Tell me what are the three examples, problems, standard problems? Parallel, congruent and similar. Parallel, similar, congruent. These three always equivalence relation. So what is the congruent? So question is there, but in textbook is there, but just direct I will explain, shortcut I will explain. So what is the R is defined T1 comma T2. Even some textbook is given congruent triangle, this type triangle, okay. The congruent symbol this is, okay. So T1 comma T2 such that T1 is congruent to T2. T1 is congruent to T2. Very simple. What is the reflexive? Reflexive. T1 is congruent to T1. But how to start? When reflexive, one element, one triangle you have to select. Now what is it? Tell me. For T1 belongs to, so you want a T. The set is T. Set is called, set is T. So T1 belongs to, T1 belongs to T. T1 is congruent to T1. So R is reflexive. What is the symmetric? Let T1 comma T2 belongs to R. For all T1 comma T2 belongs to set A, set T, because it is a set of triangles. You are selected two triangles, T1, T2 belongs to T. T1 given what is? T1 comma T2 belongs to R. So T1 is congruent to T2 and it implies T2 is congruent to T1. Okay? It is symmetrical. Then what is the transitive? We have to select two order pairs. That T1 comma T2 belongs to R and T2 comma T3 belongs to R. We have to prove T1 is congruent to T3. So automatically T1 is congruent to T3 only. The first two triangles T1 T2 congruent and T2 T3 is congruent. Automatically T1 is congruent to T3. So this is also equivalence relation. The previous one similar and here congruent. Similar, congruent is always equivalence relation. Even this problem is there in the textbook. Show that set of all triangles in a plane with R is relation is on a T is given by R is equal to T1 comma T2. T1 is congruent to is an equivalence relation. Okay. So what is the next? Parallel. That is called parallel. Parallel is also equivalence relation. What is the parallel? R is equal to 8. Better to take L1 comma L2, so that L1 is parallel to L2. R on what? Capital L. What is L? Set of straight lines. Set of straight lines. Then what is the how to start? Reflexive. Reflexive. The line. Even you take L1 belongs to T, capital L. L1 is parallel to L1. The line itself is parallel. The line itself is parallel. So L1 comma L1 belongs to R. Therefore, R is a reflection. What is the symmetry? The symmetry, very simple. You have to select that L1 comma L2 belongs to R. For all L1 comma L2 belongs to L, capital L, because set of straight lines. Now what is the here? L1 is parallel to L2, it implies L2 is parallel to L1. There are two lines are there, L1, this is called L2, L1 is parallel to L2 is given, and L2 is parallel to L1. So L2 comma L1 belongs to R. L1 is parallel to L2, it implies L2 is parallel to L1, so L2 comma L1 belongs to R, and therefore R is what? Symmetric. Then what is the next? Reflex is okay, symmetric is okay, and transitive. Transitive, given two ordered pairs belongs to R. How many given ordered pairs in R? Two ordered pairs. What are the two ordered pairs? Let L1 comma L2 belongs to R, and L2 comma L3 belongs to R. So these two pairs are given. What is L1, L2, L3? Belongs to capital L, set of straight lines. They are given three straight lines. There are three straight lines. This is L1, L2, L3. L1, L2, L3. You see, L1 is parallel to L2, L2 is parallel to L3. So automatically L1 is parallel to L3. So automatically L1 comma L3 belongs to R. Hence the relation R is equivalence relation. Request, these three are very important problems. Nothing very simple. Even everybody, so these three problems are solving. That's not difficult. So when an extra question is asking, that is what is the for example, similar triangle, another is parallel, another is congruent. In this question is there, one extra question is there. What is the question? Find the set. Find the set of all lines related to the line y equal to 2x plus 4. In this question, extra also. First question, show that this is the equivalence relation. Show that this relation R is equivalence relation. You are doing reflexive, symmetric, and transitive. Okay. In same question only, but I am not giving the questions. I am not giving. I am not writing on board. So orally I am explaining. So also find the set of all lines related to the line. Find the set of all lines related to the line means this is parallel. Okay. Problem is parallel. L1 is parallel to L4. So what is the question? Right. Find the set of all lines related to line y equal to 2x plus 4. We have to write equation of line parallel. We have to write parallel, any line parallel to this equation. So what is the line is related to, the set of all lines is related to y equal to 2x plus c. So where c belongs to any real number, where c is any real number. Okay, even how many lines you will get? Infinity. C is a real number. C is 1, C is 2, C is 3. So this is the related to of this line, because parallel means coefficient of x same only, slopes are same, only differ by constant. Just you remove the 4 and write. This is the one question. So suppose if you are asking 5 marks question, that up to equivalence relation is the 2 marks, 3 marks. So write the set of all lines related to this line y equal to 2x plus c is the correct answer. Be carefully, where c is any real number. Tell me what is the y equal to 2x plus 10x plus 10x minus 7. What is the related of this line? So what is the y equal to 10x plus lambda? Whatever you take, where lambda is any real number. Okay. So this is the important question. Questions I'm not writing on the board. Just orally I'm telling. Even 3 problems I explained orally only. Just I explained that similar triangles. Repeating once again, similar, congruent and parallel. Similar, congruent set of triangles, but parallel set of straight lines. So capital T is for triangle, capital L is the line. Okay. Next problem. Let capital L be the set of all lines in a plane R and R be the relation in capital L defined as R equal to L1 comma L2, such that L1 is perpendicular to L2. Show that R is symmetric, but neither symmetric nor transitive. Even these problems also it is orally only. Parallel, perpendicular, similar, congruent. Tell me what are these four? Parallel, perpendicular, similar, congruent. So similar, congruent, parallel, equivalence relation. So perpendicular is not equivalence. Even in CET multiple choice, they are given 4 options. Question is asking which one of the following is not equivalence relations. Even given 4 options: similar, congruent, parallel, perpendicular. So when you are perfect theory now, so without solving, just oral question, you are telling parallel is equivalence, similar is equivalence, congruent is equivalence. So perpendicular is not equivalence, because in perpendicular only symmetric is satisfied. So that R is symmetric, but neither reflexive, nor transitive. In perpendicular, only one condition is satisfied, that is called symmetric, because L1 is perpendicular to L2 and L2 is perpendicular to, but line itself is not perpendicular, not reflexive is not, because line itself is not, but line itself is parallel but not perpendicular. Even this is transitive, also not satisfied. So one by one I explain. Now solution: R is equal to L1 comma L2, such that L1 is perpendicular to L2. L1 is perpendicular to L2. Then what is the first one? Reflexive. So what is the reflexive? For L1 belongs to what? What is the set? Capital L. L1 belongs to capital. L1 is not perpendicular to L1. That is, L1 comma L1 does not belongs to R. Therefore, R is not reflexive. R is not reflexive on capital L. Very simple. Even line, in a straight line itself is not perpendicular. Itself is but not perpendicular. Even this also okay. L1 belongs to L. L1 is not perpendicular to L1. So L1 comma L1 belongs to R. So R is, so L1 comma L1 does not belongs to R. So R is not reflexive on. Even parallel it belongs to R, but perpendicular line itself is not perpendicular. Okay, but this ordered pair does not belongs to R. Then what is next term? Symmetric. So how to start symmetric? One ordered pair is given. Let L1 comma L2 belongs to what? R. For all L1 comma L2 belongs to capital L, because set of straight line. Nowadays it implies L1 is perpendicular to L1 is perpendicular to L2. It implies L2 is perpendicular to L1. It implies L2 comma L1 belongs to R. Therefore, R is symmetric. R is symmetric on capital L. So this is the line L1. This is the straight line. This is the L1. This is what? L2. You see, L1 is perpendicular to L2. Even L2 is also perpendicular to L1. So perpendicular is always symmetric only. Now transitive. Okay. Let L1 comma L2 belongs to R, and L2 comma L3 belongs to R. For all L1, L2, L3 belongs to R. It implies L1 is perpendicular to L2 and L2 is perpendicular to L3. It implies L1 is not perpendicular to L3 because L1 and L3 are parallels. L1 is not perpendicular to L3 because L1 and L3 are parallel only. It implies L1 comma L3 does not belongs to R. Therefore, R is not transitive. R is not transitive. But usually the 1 mark question in the relation, it comes difficult only. What is the question? 1 mark question. Give an example of a relation. The relation R is symmetric but not symmetric and transitive. Give an example of the relation R is reflexive. Give an example of symmetric but not reflexive, not transitive. Give an example of symmetric but not transitive symmetry. This is the good example. Give an example means it is only one step, one must question only. What is the question? That answer? Give an example of, the relation R is symmetric but not symmetric and not transitive. So what is the one line answer? The relation R L1 comma L2 such that L1 is perpendicular to. Although the relation R is perpendicular to in the set of straight lines in the plane is always symmetric but not reflexive and not transitive. Tell me perpendicular, reflexive, no reflexive, symmetric, yes symmetric, transitive, no transitive. So perpendicular, only one condition is satisfied, that is called symmetric, no reflexive, no transitive. Okay. So give an example of reflexive, symmetric, transitive. So many examples. Even parallel is there, similar is there, congruent is there, many are there. Okay. This is also important. So repeat it once again. Perpendicular, it is only symmetric but not reflexive and transitive. Next question. Show that the relation R in the set Z. Show that the relation R in the set Z of integers given by R equal to A comma B such that 2 divides A minus B. 2 divides A minus B is an equivalence relation. Even set, what is that? Z is the set. Integer is the set. Okay. So all the elements belongs to integer only. Okay. Not belongs to R. So this is also important question. So 2 divides A minus B. 2 divides A minus B. A minus B is divisible by 2. I think A minus B is divisible. A minus B is 2 into some integer. I think A minus B is even number. Okay. Is a multiple of 2. Right. Solution: R is equal to A comma B such that 2 divides A minus B. So very important, students, reflexive. So way of writing, but problem is starting. Students, they know the answer, but write the step means they don't know. So reflexive, I am telling, only one element you have to select, but you have to prove related itself. Suppose A comma A, B comma B, but A belongs to what? A belongs to not R, A belongs to Z. So I am taking for A belongs to Z, okay? For an integer I am telling, it implies 2 divides A minus A is true only, because 2 divides 0 is true, because 0 is a multiple of 0 is divisible by 2 only. So 2 divides A minus A, even 2 divides 0 is 2, that is A comma A belongs to R. Therefore R is reflexive. R is reflexive on Z. So this is the reflection. Repeating once again, you select not only A, you can select any number. Even elements also is no problem, but generally you have to write. Generally only write. A belongs to A minus. You want 1 minus 1 minus 1, 2 minus 2 minus 2, 3 minus 3 minus C. So I am taking A belongs to 2 divides A minus C. That A comma A belongs to R. Therefore is reflexive on. No, it is true because 2 divides 0. 2 divides 0 is always true. 2 divides 0 means 0 is divisible by 2. Okay. Now it is reflection. Then what is the next? Symmetric. Symmetric we have. Symmetric. Symmetric. How many ordered pairs are given? Only one order pair. How many elements? 2 elements. What is the given order pair? Yes, A comma B belongs to R. For all A, B belongs to Z. Given A comma B belongs to R, for all A, B belongs to Z. It's what given means what is this is 2 divides. 2 divides A minus B. When 2 divides A minus B, 2 divides B minus A also. It implies B comma A belongs to R. Therefore, R is symmetric on Z. A minus B, B minus. This is standard only. A minus B integer, B minus also integer. Properties of integer. Okay. A minus B integer, B minus also integer. Even actually minus common. 2 divides minus or 2 divides B minus. No problem. Even we can write directly, no problem. A minus B, here what? B minus. So symmetric also it is satisfied. When 2 divides A minus B, and it is also called what? Symmetric, because 2 divides B minus A. B comma A belongs to R. R is symmetric on Z. Now it is very important what? Transitive. Transitive. Now number 3, transitive. So how many order pairs are there in a transitive? How many order pairs are given, students? Yes, 2 order pairs. Very good. So how many order pairs are given? 2 order pairs. We have to prove 1 order pair. So what type of orders you are taking? Yes, A comma B and B comma C. So we have to prove A comma C. Very good. So you have to select A comma B, B comma C. Okay, we have to prove A comma C. When A comma C means A minus 2 divides A minus C. When 2 divides A minus C, we have to prove A minus C is even. When you got A minus C is even, then definitely A minus C is what? Divisible by 2 or 2 divides A minus. Let A comma B belongs to R and B comma C belongs to R. Yes, correct. How many elements? 3 elements. For all A, B, C belongs to integers. It implies 2 divides A minus B and 2 divides B minus. When given 2 ordered pairs, then what you prove? We have to prove 2 divides A minus C. Now A minus C. Now 2 divides A minus B and 2 divides B minus C. Now A minus B is what? Is divisible. A minus B and B minus are divisible by what? 2. Now A minus C A minus C equal to A minus B plus B minus C. Now totally this is called even, because A minus B is divisible, means A minus B is 2k1 and B minus C is 2k2, because both A minus B, B minus C both are even number, and A minus B plus B minus C even number. A minus C is divisible by 2. It implies 2 divides A minus C. It implies A comma C belongs to R. Therefore, R is transitive on Z. I'll repeat once again. Let A comma B belongs to R and B comma C belongs to R. For all A, B, C belongs to Z. 2 divides A minus B and 2 divides B minus. These two are given. We have to prove 2 divides A minus C. So what is the very important? 2 divides A minus 2 divides A minus B and B minus A are divisible by 2. Are divisible means A minus. Are divisible. A minus B divisible means A minus B is 2k1 and B minus C is 2k2. Okay, I think A minus B, B minus A, totally what is this answer? Even. When it is even, no, A minus C is divisible by 2. So when A minus C is divisible by 2, 2 divides what? A minus C. So A comma C belongs to R. R is transitive, hence the relation R is equivalence relation. What is the statement? Relation R is A comma B, 2 divides A minus B is always equivalence relation. The very important is transitive only. In transitive, A minus C, A minus B plus B minus C. A minus B plus B minus C, totally your answer is even. A minus C is even. A minus C is even means A minus C is divisible by 2. So 2 it divides A minus C. A comma C belongs to R. Hence it is equivalence relation. Today's class. So parallel, similar, congruent, perpendicular, even the 2 divides A minus B is equivalence. And tomorrow the class number 5 continue. The fourth class number 4 will continue tomorrow. Still so many problems are there. So one more class is needed, the relation. Then I will start functions. It's hardly one period. It is the 4th period is going. So one more last period. I will finish the relations. Then we'll start functions. Thank you.